welcome to our last session on our webinar series on effective test strategies for microservices. It's 7:30, so we'll start our last session here. So just give me a right. So let's do a quick recap on the last session we had. In the last webinar session, we discussed about what static checks are and what are the best practices associated with them. We also discussed on what unit testing is and what are the best practices associated with unit test. Along with that, we also seen what contract test and integration test are and what are the best practices associated with these, right? Along with these, we also looked into the testable strategies and how to opt for the optimal test double based on the scenarios and how to gain most out of it, right? With this, we also had a quick code demo in which we had shown how to run your integration test, either broad integration test or narrow integration test in your build pipelines, right, where you can spin your microservices and gain most out of it as part of running these tests in your build pipelines. So what were the key takeaways that we had in the last session was to test deep, test early, and test all in your build phase itself. That means, you test everything everything as much as possible to gain the right confidence and to ensure that everything is working fine when anything is being merged to master, and the code is available is a prod ready or a stage ready, we call it, right. So that's what we were the key takeaways to test early as possible. The next was defect reaching into a test environment or staging environment itself is late identification, and we also have to ensure that we shift the mantra that we've been talking about, shift left. So the entire fundamentals are to how to identify these defects early in the build cycles or in the PR builds itself before it gets merged, right? So that it does not get slipped onto a staging environments or into the subsequent environments later on. So these were the quick key takeaways from our last session and a quick recap on what we discussed. Let's move on to the today's session's agenda. We'll be discussing about the black box testing approaches for microservices and the two types of tests which are associated with it, which is service level test and the end-to-end test. We would look into the defect retrospection exercises and what are the and the effectiveness of it. We'll also look into what is measuring quality and what do we measure and how should we measure. Along with that, we'll also look into what engineering practices that matters to the microservices teams and the key takeaways from our session today. Now, let's look into the black box functional testing approaches, right? The black box functional testing revolves around testing how the consumer is going to consume a microservices, right? It validates the behaviors of all the microservices stitched together. Are they giving the right results, right? When the consumer flows are, or let's say the consumer scenarios are being executed and the workflows are being executed. So also these functional tests, right? The black box tests, they execute in the live environment. That could be your staging environment or a queue environment. So that way it gives you it boosts up the confidence and identify the loopholes in your critical flows, because we expect all the dependencies to also be available, and these tests actually interacts with the live dependencies. So there is no mocking and stuffing which is generally being used, and gives you the the additional confidence which is required that all the integrations are intact and the consumer workflows are working as expected or not. So there are two different types of tests which are associated with the black box functional testing that we were discussing. One is your service level test. So these service level tests are being written generally at a microservice level, right? So these tests actually helps you to identify any early gaps in your configurations, right? Let's say if your microservice interacts with 2 3 immediate downstreams, so having these service level tests would ensure that your configurations are intact for your microservice, and you're being able to interact, you're being able to post a guest, you're being able to send out a post request, the authorizations are being verified here, and you're being able to receive responses. The serialization and deserialization also is being working as expected, and the contracts are intact. And you could also verify the critical consumer features, the capabilities that microservices is offering to ensure that your microservice is highly available, and you don't introduce a blocking defect or once a service deployment happens. So these tests really becomes handy here. Uh, the service level test here. So moving on to the next category of tests that we would see is end-to-end regression test, which would also discuss in detail in the coming slides. So these end-to-end test differs from service test, from the matter of fact that these end-to-end test concentrates around testing the entire user journey, how the consumers are going to interact with the mesh of microservices, and are these microservices stitched together, it provides the right consumer journey or not, right? So these end-to-end test regressions becomes very handy also to give that additional confidence which is required to ensure all these microservices, when stitched together, they've been working seamlessly, and there are no integration gaps or communication gaps which comes later in the cycles, because microservices do work from the very fundamentals of having independent deployments and independent developments, right? So with this, let's move into what service level tests are and what are the best practices around it. So usually a service test would look like this, where you have a test client, which you could use any test client for that matter, based on what programming language that you're using beneath it, right? And this client would be responsible to making a call to your microservice, which should be received by your controller layer, and the microservices will process it and will give you a response back. So this test actually treats your microservice as a black box, and all we care is if for the given workflow, am I receiving a right response from my given microservice or not, right? So these tests actually concentrate around only a given microservice and the capability it offers. So one of the key factors to look into these tests is keep these tests precise and quick. With that, what we mean is, keep these tests very focused. Only add the critical workflows that you want to verify here, and make them quick, because as these service tests also sits on top of your pyramids, and the more scenarios that you add, it could become time consuming and would become flaky with time, right? So it's important that you keep these tests precise and quick to get most out of it, right? And keep these and helps in keeping the maintenance low with over time here. So next is auto trigger these upon each deployments, right? So as we were mentioning that, right, these tests actually interacts with your immediate downstream services, real downstream services, and helps identifying that they are not any configuration gaps, or they are not any authorization issues which you could not be able to verify in your white box testing that we have discussed in the last sessions, right? So when these tests actually runs as part of your deployment, that gives you a boost up, and you can actually make these tests to decide whether your deployments are passed or failed. And let's say when the deployment happens and you run these tests immediately, and if the test passes, you see that your deployment is success, and you can decide on the subsequent steps. But in case if these tests fails, you can roll back your changes, right? And you can then quickly fix these tests and make your deployments green again. So these tests actually becomes a key factor in identifying whether your deployment is going to be success or not. See that these are being added as part of your CI/CD pipelines, and makes the decisions on your deployments here. Moving on to the next is Also, as part of these service level tests, right, also add coverage for your consumer facing features, right? With this, what we mean is the microservices actually works for domains, and they are built to provide capabilities and features to the users. So when you write these service level tests, uh, along with ensuring that your immediate downstream services configurations are intact and you're being able to interact with them, also add your key capabilities which you're being offering, and the features, if you see that if not being met, that becomes a blocker, right? So add those features onto these tests and see that those are always being green. For example, let's say if your service is a checkout flow service, right, and if a user is not being able to check out, if it's not being able to place an order, then uh, that becomes a blocking issue. So ensure that you have a basic test which runs through your checkout flow and able to place an order. And once that is being success, you can see that your deployments are going to be successful because your uh, critical flow is not being blocked. It's running as expected. So add these critical flows or which are going to be used by the consumers, or the capabilities that you're offering also as part of the service level test, but along with this, make them precise and quick. That's also a key factor here. So the next is along with run these tests continuously on a schedule. So we know that we are now running these tests as part of a deployment, so to ensure that everything is working fine when there is a deployment happens. So now question comes is, why do we want to run these continuously? So let's say what happens is, what we have seen is, since your microservices usually gets deployed on cloud instances, right, and one of the key factors of microservices that is being based on is high availability. That means that if there is a deployment happens, and in on the cloud instances, if there is a node going down and a node which is being brought up, there is no effect of you would the consumers would not see any effect of it. And to ensure that there is no additional latencies being added to your services when these happens in the background, you run these tests continuously. So these are the fee the few of the advantages that you get when your tests are being running continuously, let's say every 20 minutes or every 15 minutes or every 1 hour, and they give you the right reports on how your service is being performing. And along with that, since in the first session we have discussed about capturing the alerts and monitoring your P90 and P99s, right? So running these tests continuously also feeds into your uh, staging environment or queue environment, and feeds into these signals. And then you'll be able to see that are there any breaches on your SLAs that you are being committed. And if there are any SLA breaches in your staging environment, that's something that needs to be looked upon, because that could also happen in your production. So so these are the advantages associated with running these tests continuously on a given schedule, and should so every microservice team should really make use of it. The next is set real-time alerts, right? So uh, as these tests are being running on schedule, it's also important that we monitor these tests, right? And if in case there is any failure happens, we see that these notifications are being these notifications are being passed on to the teams, and they can actually look into these failures as soon as possible, because quite possible that because of these failures could be of very genuine cases, and could might get slipped into production or to staging, and might cause some issues there, right? So and results into defects. So it's important that you keep a real time alerts on these tests, and if there's a failure happens, that has to be looked upon immediately. Also, what we seen is, when we run a test, sometimes we don't see those race conditions that happens with the microservices, right? And those are intermittent in nature. But having these tests running continuously and setting up the right alerts, you'll be able to identify those scenarios also where the race conditions might happen in your service, right? And you would be able to fix them more efficiently. So that's an advantage that you get on keeping the real-time alerts for these service tests. So moving on to the next is, keep these tests close, in the same repo as your microservice source code is. It's one of the good practice that we've been advocating through a journey. And the teams could gain a most out of it when these tests are closer to your repo, because ideally, for the microservices, the very very common terminology that is being used, right, that you build it and you run it, that means it's the same. It's a one team that is responsible for the entire microservices designing, development, also to testing, and then deploying into production and doing the operational, and taking care of the operationals and fixing the hots, right? So when these tests are also in the same repo, it becomes closer to the teams, and team can also identify when the tests are needed to be added to the service level test at a right time, right? That's one advantage that you get. The other is, since most of the services are of different technology stack, and what technology stack is being used for your microservices, if you also uses a similar stack for your service level test, you gain most out of it. So that's an advantage also that you get while keeping these tests on a same repo, right? And teams gets more responsible when it's in the same repo. You could also keep an eye on what is being added, what is being removed, right? There's more effective PR reviews that we have seen here. So it's a good practice to keep this test within the same repo here. So these are the common, these are the very good best practices associated with your service level test, and you could gain most out of it when these are being incorporated in your project. Moving on to the next is, let's look onto the next category of tests, that what we were discussing about is end-to-end regression testing, right, or the end-to-end functional testing. So they are these end-to-end tests, if we have seen our earlier test pyramid that we have shown, right? So these end-to-end tests, it actually sits on top of your pyramid, right? And what happens with these end-to-end tests as we move up the pyramid is, there are challenges associated with this, right? So let's look into the what are the common challenges that team faces with these end-to-end tests. So one is, since these tests sits on the top of the pyramid, where you look at how the consumers are going to consume your microservices, which could be more than 10 plus services. You could have 15, 30 microservices in your platform, right? And so hence it becomes hard to build that context, right, for these end-to-end tests, on what workflows that needs to be added and what assertions to be added, right? And what the test is actually doing it, when more and more complexities and capabilities are added to it. So that's one. The next is, since these test since this end-to-end test sits on the top of the pyramid, right, and this spans across all the microservices which are available in your platform, it's also difficult to identify where to keep these end-to-end tests, where you can get most of the attraction, right, where you get effective reviews and effective contributions from all the services involved, right? So that becomes actually difficult to get the right people in, looking at those tests and reviewing if you are verifying the right scenarios here. uh, the next is, if let's say if these end-to-end test fails, right, because these tests runs in a staging environment where you have all the dependency, you uses all the real dependencies, right? And when the test fails, it's hard to identify because of which service the test failure happens, which service to look out, and for the fixes. And often we have seen that sometimes teams also ignore these test failures, because if these tests have been very flaky, team have this notion that, okay, the tests have been failing for so long, so what happens if the test is still failing? So it's easy to people ignore the test failures for these end-to-end tests, and it's easy also to miss the failures here. The next is, there's a high maintenance involved for these end-to-end tests, right, when the feature grows, because uh, with depending on the number of microservices you have in your platform, your user journeys are going to get complex with with each release, with each capability of feature that's being added to your platform. And what we have seen is the test grows in the complexity, and hence the maintenance also grows, right? Because if the test becomes complex, that means it's easy to it becomes easier for the test to become flaky. And let's say if they are being contract changes by services, and you have to come back and update the contracts here. If there is a new flow added, if you want to update the existing flows, that means someone has to come back to these tests and update these tests. And then that means you have to understand the entire complexity of the existing framework, and what the complex workflows are, and what workflows needs amendments, and what workflows needs deletion now, because that feature is being modified and that test does not make any more sense, right? And then adding, do we need to add more tests to it? So this entire maintenance becomes high with time as the feature grows here. The next is, since these end-to-end tests interacts with real dependencies, and quite often, right, when these tests fails, we don't know what service is being the failure of it, right? And often what happens is, as microservices also grows, and there's a lot of there's a lot of capabilities or new features added to the microservices. uh, we also seen that there is a performance regression that happens, right? There's a latencies which are being introduced by the services if performance testing is not being taken care of here, and that adds to the uh, instability of these end-to-end tests. Because if the latencies are not being met, if the microservices are not now meeting their SLAs, we would see that your end-to-end test would not receive the responses on time. They'll go timeouts, and then you have to reach out to the right teams again, and why the responses are not being received, and I'm receiving a wrong response here. So it's because of all the different microservices involved, right? It adds a lot of instability to these tests here. And right, so those are the common pitfalls that we have seen associated with these end-to-end tests. So now let's look into the best practices for these end-to-end tests that would help you to address these common pitfalls, and to see that your end-to-end test actually makes you make the most out of your end-to-end test, right? Because as long as your end-to-end test provides you the right results, and if they are running as expected, and if they fail because of the right reasons, and you're been able to identify defects, that means your end-to-end tests are in good shape. And if they're being flaky and there are a lot of false positive, that means you have to look upon these best practices again, and then you have to go back and restructure your end-to-end testing strategies again, right? So let's look into these best practices that would be helpful to maintain a healthy end-to-end test suits to the teams. The one is, first is to identify what scenarios that you want to add to your end-to-end test, right? I would really want to call out that it's not going to be one time effort, but something that you have to keep investing on it. Keep a regular, let's say quarterly checks, that what scenarios are available in your end-to-end test. Those are the critical customer journeys or not? Now the question comes is, right, how do we identify whether it's a critical customer journeys or not? So that is where what you could do is, reach out to your PMs, right? Or reach out to your PMs, or gather the data from your production on what are the flows that customer uses to the most, and what flows, if is not working, that is going to raise a P0, or let's say a blocker issue in production or into your staging environment. So add those critical journeys only to your end-to-end test, right? To ensure that you do not see, to ensure that you keep these suits smaller, and when these tests runs, they give you the right results, and you're being able to identify these blocking issues early itself, right? So that's important, that to keep your test suite small. And this is going to be a recurring activity, because as more and more capabilities are added, and if you're updating your end-to-end test suites again, that means there are more chances that that list would grow. So that means, keep investing a time where you come back and review, are the tests are now making sense to us, and is it right to invest on these tests or this number of scenarios that are added? Because also, right, if more number of scenarios are being added to your end-to-end test, your pyramid shape is going to fall, and that means that's going to cost you in terms of maintenance and you know in terms of maintenance and the test execution times here. So see that you have only the critical customer journeys, and you keep in check of the number of tests that are being running as part of your end-to-end test suites. The next best practices, uh, prefer executing these end-to-end tests and the workflows where the proxies, right, which has access to all your downstream. For example, when you're working in your projects, right, and you have the user experiences that are going to interact with your microservices platform or mesh of microservices, if they are going to interact via a proxy or a gateway, see that your end-to-end test also uses the same journey how your consumers are going to interact to your microservice platform. So that also ensures that are there any authorizations that are needs to be, authorizations are working at your proxy level or a gateway level, and that will give you right confidence, whether the routing is working as expected, and all the request responses also received within the stipulated time. So the next is do a logical distribution of the monitoring responsibility, right? So as we were saying that with these end-to-end tests comes a lot of responsibility where when the alerts, in when there's a failure is being seen, and to ensure that the teams are being alerted for the failures, and the teams looks into the failures as soon as possible and fix these end-to-end tests as early as possible, right? So to reach to that state, what you could do is you can, you know use a roster within your teams who would be responsible on keeping an eye on, whenever there is a failure happens to these end-to-end tests, you notify the right teams to look into it, and chase them towards getting the fixes available as soon as possible, because having these tests running healthy all the time should be the utmost priority, and that gives you the right confidence, before you hit production, that everything is working fine. So doing this logical distribution for monitoring helps you achieve, in addressing these alerts on time and getting to a resolution. uh, the next is keeping these end-to-end test suites light as possible, right? So that's something that we've been discussing, that if your end-to-end test suite grows in terms of complexity, the high chances are that it gets the flakiness is being introduced with time, and the cost of maintenance also increases. So keep ensuring that your end-to-end test suites is light as much as possible. And in case if you feel that there's a complexity is being introduced in terms of how the tests are being written, and they are very heavy in terms of the number of flows a single test executes, then better to again, restructure your test and make them light again. But right, so that will help you to keep your test execution times in check here, and making these end-to-end tests more resilient with time. The next is run these tests at a high frequency, right? So since these end-to-end tests sits on top, and they actually verifies whether all your microservices together are working as expected or not, right? They are the consumer journeys are being achieved, and there are not any issues observed, right? So often, because of the communication gaps between the teams, right, we have seen that there might be certain, contract breaches that might get slipped into into the queue environments or to the staging environments, right? So running these end-to-end tests at high frequency would ensure that even if these microservices are working in, independent deployments and development, you'll be able to catch the defects early, because if there are 15 microservices or 30 microservices, right, they will be doing a daily deployments onto your staging environment. So just to keep an eye on all the critical flows, all the critical consumer journeys are working as expected, irrespective of how many times your services do a deployments, I think the best would be to not run these at a high frequency and see that these tests are not breaking. And that also helps you to identify if there is a race conditions being seen within the services when all the services together are working, right, to achieve a consumer journey. So moving on to the next, right? So right, just my bad, right? So use the right test assertions here, right? Right test assertion strategy. So what we mean by the using a right test assertion strategy is uh, in that QA world, right, we know that there are two different assertions available. One is a hard assertion and soft assertion. And soft assertion, which is available in the market and known in the market for quite, it's been 2 decades or older than that. But but then it gives you a very good control in terms in how you're how you're going to design your test, right? What we mean by this is uh, for your microservices, right? Your each microservices actually are controls a domain, and they tries to achieve your domain's principles, and they have entities associated with it. So when these microservice when you actually test your end-to-end test through a user workflow, you would also want to ensure that these domain entities are being are at the right state at the end of your test. So now what happens is when you use a normal assertion, which is a hard assertion, if one of your domain entity is not at a right state, it will fail then and there. And then you might have to, once you fix it, and then you will see that, oh, there is an issue again on this response, and we should have really identified it earlier. So, so in your responses, the entities which could be asserted independently, that is where you could use a soft assertion, where soft assertion techniques, where it will give you the all the errors that you have seen in your end-to-end test at the end of your test execution, and then you can make a decision whether your test needs to be fail or pass, right? So usually in the test, I would not say that you should always go for a soft assertion, but but you have to make a right balance and choose between when to use a hard assertion and when to choose a soft assertion. And choosing and using the hard assertion and soft assertions together make your make your end-to-end test more effective, and you'd be able to see the right errors and all the right errors with one test execution flow. And once you are able to fix it, possibly the chances increases more that when you run it the next time, it's going to go to the green. So it's important that you also pay attention to what assertion techniques that you're using in your test, and see it's an amalgamation of both soft assertion and hard assertions. And I don't think so soft assertion is language pairs. I think most of all the languages that you're using, either JavaScript or TypeScript or Java for that matter, Python, there always support for soft assertions, or you could create wrappers around it. So use the right assertions techniques for it. And before we move to the next slide, I just want to call it out in my opinion, right? So uh, your test is nothing but the assertions that you use in your test, right? if your assertions are if your assertions are not right, that means even if your test is running, it might not catch the right bug. So the entire uh, the entire effectiveness of your test lies within your assertions, right? The more effective assertions you have, the more effective your test is going to be. So pay a key attention to what assertions you're using, and and use the right assertion techniques for your end-to-end test, right? So I think let's move on to the next slide. So far what we have discussed is about different the different uh, the different tests we have within the test pyramid, right? And what are the best practices around it. So what happens is, let's say if you see an issue at each and every stage of your test, right? So usually those are being reported as a defects. So Now let's look into the defects retrospection, because it's an effective exercise to gain the insights on what's happening when your services gets deployed, and can also helps you to improve further on your existing uh, quality artifacts or the testing artifacts that you have within your teams. So the first is, just give me a minute. Yep. So the first is regular defect reviews, right? So as I was just mentioning, right? So the defects are actually being the byproduct when your service is being deployed, and tells you whether there is a customer journey, the customer expectations are met or not met, right? So if something expectations are not met, that is where we raise as a defect. So ideally speaking, and I would also advocate, right? So even when you're writing your service level test, which is within your boundaries, and if you identify that your service level test is failing when the deployment happens, you know instead of creating a task in Jira and then fixing it, ideally raise a defect for it, right? And then try to fix it. Similarly, if you see any issues in your end-to-end test, raise defects for it, right? So what will happen is you would get these defects at different layers, which involves your service test, which involves your end-to-end test. And let's say if there is a UAT testing happens, a release testing happens, you capture those defects. And then if there's, when you deploy your service to production, so take these defects and review on a periodical, in a periodical, at a regular frequency, to get more insights here. So that will help you to identify what further improvements are needed, and are the testing layers that you have added and the tests that you have added for each layer, how effective they have been to identify a defect before it moves to before it gets slipped to the next stage. So these regular defect reviews are very important here, right? The next is convert these defects into test, right? So so for microservices, the teams do advocate, right? It's one of the best practices to use a TDD or test driven development approach when you are developing it. But what we have seen in the market also, that most of the teams are not very comfortable with a TDD approach, right? So if that is the case with your team and you have not been following a TDD approach while doing a microservice development, so but this practice is very good and the teams have gained a lot, right? But something you're looking to gain most out of it, start from your defects. So that means whenever defect is raised, instead of directly fixing it, use a TED approach for your defect fix here, right? Where you add the defects which makes your app service fail, and then you provide the right fix to ensure that your tests are now passing. So that will makes your teams also comfortable with the TDD approach, where you could actually leverage it later in your development cycles. Along with that, it will also strengthen your existing test at different layers by adding the test which were missed earlier and which has caused these defects to slip to the next layer, right? So so having a TDD approach for fixing the defects would really help to strengthen your existing test pyramid. The next is doing a defect retrospection, right? It also brings the process efficiency. So what we mean by the process efficiencies, let's say the first is how the defects are being raised, right? So often what we have seen is when the defects are being raised, if the right information is not being captured, that is where it takes a lot of time for the teams to evaluate, right? And there's a lot of to and fro happens even before the defects gets accepted and the team starts working on a fix. So uh, so it actually helps you to bring out what are the different gaps and where the defect fixing is taking a lot time here. So that's one area where it actually helps you. So that means in case if you want to have more effective use of your defect management tool that you're using, right? And to capture the information first hand, the first hand information correct. So it'll so you can actually add these process enhancements there to ensure that everything is, that you can minimize the gap between when the defect is being identified and the when the defect gets accepted that it's a valid defect, and the teams are going to provide a fix for it. So it helps you bring that makes that process lean. The second is often what we have seen is the teams also, it gets very late to the teams that there is a defect being raised on them. So if you also also as part of your defect retrospection, see how long your teams are taking to identify the defects are being against them, or it reaches to the team, right? And if you see that there is a time, the time is longer, the duration is long, and that is eating a lot of time, so you can add again the process improvements here. So what we're trying to say is, uh, as a QA, it is good to raise as many as defects that we can, right? It's good to identify the defects, but the more number of defects are being raised and the longer the defects takes to fix, it has a side effect on your release dates and when the code is going to hit production, right? So doing this defect retrospection exercise would actually helps you to bring these process efficiency at every state. The first is, are the defects being being accepted immediately by the teams or not, or are there any delays? Are the teams getting the right defects, are the right defects reaching to the teams on time or not? And then you can also create the right dashboards for your team that gives you the right live pitches there, right? And you can also increase on process on the communication, right, between the teams. Also, let's say if there are being defects identified, do a root cause analysis and see that where the what at what layer your test were missing, and that has caused the defects to slip. So then you can also bring out those process, you can bring out those enhancements within the existing quality artifacts that you have, or the existing testing strategies that you're using in your teams. So moving on to the next is, it it improves the triaging, right? So as we were discussing, what happens is, as part of what I would like to call out is during the defect retrospection, right? To keep in also keep these checks, how long the defects are taking to get identify the teams, right? And see that what are the process improvements here required. And also what we have seen is when there is a lot of testing happens, and when the and when you're going to hit production, right, and there are different teams involved, of sometimes there's a harmony that gets lost between the teams because of like a lot of to and fro. So when you do, so these retrospection exercise also helps you to identify these gaps between the teams, the process, the communication gaps between the teams, and you can work later on, to improve these better. And how could you help teams to work in harmony, together in more collaboration. So that is where it actually helps you to care to improve your triaging processes also. Okay, just right. So next is, it helps you to build the larger context. So what happens is, since for microservices is one team, is being managed by one team, and then all microservices teams work independently. They do development independently and deployments independently. Often it is being seen that there is the teams loses the context outside their microservices, right? And they fail to see the bigger picture and how the entire microservices are going to use by the consumer. So as part of these defect retrospection exercises, when we build up an RCA, right, what happened, why these defect was slipped, it also helps the teams to see from the consumer angle how their services are going to get consumed, right? And that helps them to identify those scenarios which they have not thought of, and hence they could actually document these user journeys, which they could refer on the coming feature enhancement and capabilities, to ensure that these scenarios and these edge cases are also being discussed in the next feature development. So that this also becomes, you know uh, uh, gets involved within the teams, right? So so that helps the teams to bring that entire context, how the consumers are going to use their microservices, and that helps for a better solution approaches and also designs, that what we have seen. So hence these defect retrospection exercises becomes very handy and important for teams to build up that entire context here, right? So let's move into the measuring quality, and I would like to give the control back to Anshul here.
Yeah.
Anshul, you there?
Yes, absolutely.
Right, just give me a minute. Uh, yes, Anshul, I think I have made you host.
Awesome. Yes, I got the control. Thank you so much, Preeti. All right. Hello, everybody. Let's take it from here. Let me share my screen. Here we go. All right. So now is the time when we talk about measurements, essentially all the activities, all testing, all defect retrospections, black box, white box, everything we have learned already. Now is the time that we measure how we are doing, right? It's just like an examination that we give in our schools or colleges, right? So what is quality measurement, right? It's about quantifying the efforts and the outcomes of the quality activities we are performing in our team. It's essentially evaluating whether we are going in the right direction with regards to the testing efforts that we're making, or if there's a need to course correct anything, right? So let's look at the major reasons why we are looking to measure the quality activities or the quality of our microservices. One is a reality check, right? It basically means that when you assign some numbers to, to the efforts or the outcomes, essentially makes it tangible and tells you where, how good or bad you are performing on ground, right? So for example, a reality check is, that you're saying you have good automation coverage, but when you drill down against, you calculate the numbers, it comes out to be just probably 50-60%, right? So this number of 60% makes your effort tangible, and it tells you that there is 40% gap still, right? Next is highlighting risks, right? So these quality measurements will will help you figure out what are certain areas that needs immediate attention, right? Areas which are problematic, areas where the quality isn't consistent, areas where teams need to focus on, and things like that, right? So that is one of the other reasons why we need to measure. And the last and one of the most important reason being showing the trend. So when you start capturing facts around quality, or you start measuring quality, over a period of time it becomes a trend, right? Now a trend or a pattern can easily help into figuring out the focus areas, right? So let's say there's a declining trend on the automation coverage. Now that's an alarm to the test automation team, right? Which they should pick up, as soon as they get these, these measurements published to them, right? So reality check, highlighting risk and showing the trends, or showing, the patterns of the behaviors that your microservices exhibit. This is why we do quality measurement. How can we do this quality measurement? We start capturing the facts. So the best part of measurement of quality or assigning certain metrics to your quality efforts is that it is non-opinionated. That means it's not qualitative, it's absolutely data. It is which speaks truth. So there's no argument about whether the numbers are right or wrong, because they're captured from the real fact, right? For example, test coverage, if the total number of tests are 500 and your automated tests are 300, it's a fact that there's only 60% automation coverage. Like, it's as simple as that. Once you capture these facts, you accumulate them in a, in a format which is easily consumable by your stakeholders. You start with your peers in the QA team, maybe developers, engineering managers, and even beyond that. So you accumulate this data and publish your information to the right set of people. That is where it will help you to bring the visibility that you're looking for. And finally, based on this information, the teams can sit and drive out some initiatives to fix the problem areas. So you basically end up taking decisions which are data driven, right? So this is basically a journey from starting to do some activities with the goal, and over the journey, you're trying to measure at each milestone, how are we performing? And during that, we publish certain numbers which actually keeps a check against the targets, right? And which helps you course correct during the journey, right? Wherever there are numbers which are not in your favor, right? That is where you can take some hard decisions as well. I mean, right, with regards to maybe changing the test strategy, or adopting some other approaches to testing. So this is what measuring quality means. Now let's look at some of the popular engineering metrics that you can measure, or some of the metrics by which you can measure the quality outcomes of the quality efforts, right? So let's start with one of the very basic QA metric, which I believe every QA team should have, which is the test automation coverage, right? How you can approach it is, you can divide your entire microservice into modules, or your system into modules, and then cover up, on a monthly basis, or, by sprint wise or quarterly wise. So you can you can make your changes to the time period according to the data, you need. Have some numbers, have these numbers are real, facts, which is already, stored there in your test management tool. So you can have these numbers and then find out the coverage. So what you see that over a period of 2 months, the test automation coverage have increased, overall. So that gives a positive sign to the stakeholders that we are improving on our coverage, which essentially would mean that our testing turnaround time is eventually getting reduced, right? Similarly, there's another very important metric, which is number of defects found by test automation. So you would face this question a lot of times, that what is the value that automation is adding, right? And you go to the very basic question, that what is the value testing is adding, right? The test is written to find defect in the right time, right? A defect found later or a defect not found is basically, defeats the purpose of doing all testing efforts. So with automation, if you're able to capture the number of defects, over a period of time, and you can distribute it across priorities like P1, P2, and so on, like critical, major, and so on, right? It'll help you carve out that what is the share of defects which have been found via automation, right? And that too in the testing environments, right? So before your build went to a production or into customer hands, you were able to find out some major bugs via automation itself. So it's like an early detection, because you run your automation very regularly, far before the releases are planned, right? And it'll help you make sure that your test suites are credible over a period of time. The next one is test automation execution time, or you call it as turnaround time, right? So you do automation for 2 basic reasons, right? One is save your effort, the repetition, and another is save time, right? So the value or the outcome of your automation should be to save some testing time, right? And that is what you're trying to capture with your test, or this metric called execution time. Now, what it will help you do over a period of time, it will compare the proportion in which your number of tests are increasing in the test automation suite versus the amount of time increasing, right? So you can figure out whether you need to parallelize your tests more if your time, if your regression time is getting increased, or if you need to do some vertical scaling or horizontal scaling, or just your code needs a lot more refactoring. Maybe your code is not optimized enough. Maybe it has some hard weights, stuff like that. So these numbers will essentially tell you that your code needs rectification with regards to the execution time of the overall regression suite, right? So these numbers will put a clear visibility and a picture of how your automation testing is kind of useful on ground, right? Let's look at some of the other popular engineering metrics, which are a little beyond just testing, but for the larger engineering teams, right? One of them is average release frequency. Now we are in an area where we want to deploy as fast as possible, right? So we just don't want to wait on deployments. We use techniques like progressive rollouts, excuse me, and feature flags and whatnot, to make sure that our code is not stuck at any testing stage. It is continuously getting deployed via CI/CD pipelines and all. and it reaches the customer hands as early as possible, right? So in this sort of attempt, it is very important for engineering teams to know that how frequently are they pushing their code to prod, right? And if there are any roadblocks or any patterns that they can find in deploying their code or moving their code from a QA environment to a production environment, right? So you can calculate the average release frequency of your product, of your microservice, right? So let's say per microservice, you can find out the average number of days, which a build takes from first it deployed to QA, from the point from that point to the point where it is deployed to production. So the average number of days for all these builds moving from staging to prod is essentially your release frequency, which you can visualize via some charts as well. If you see on the right side of the screen, over a period of 3 months, we have captured that there is one microservice, which is service 1, where the average release frequency is going down, right? Which is basically the frequency is going up, right? That's the correction. The number of days it takes for a build to be taken from QA to prod is going down, right? It's a positive trend. While for the service 3, it's a negative trend. So they need to figure out, what is taking more time for them to deploy. Is it just that their testing strategy on staging environment is, causing roadblocks? Are there more defects on staging which are caused? Is the CI/CD pipeline not equipped enough to deploy it on time, or any other reasons, right? But you get that insight that the problem lies with the deployments or the speed at which you are deploying the product, right? So this is one very important metric which you can use in your teams. Then coming to another very important metric, which is build time. So as you keep, as the devs keep adding more dependencies, in the code, more libraries, more code, your code gets bulkier, and more units and integration, contract tests and all that. So your build time would increase, the time to compile and put your code to a test environment, right? So it will increase. However, you need to make sure that this time doesn't go beyond control, because, you'll have situations where you need to deploy a hot fix and you just don't have time because you're losing customers or losing revenue. So you need to make sure that your services, your microservice can be deployed at the maximum speed, right? Which means your build time have to be always under control, right? And which is easily capturable via your CI/CD tool, right? You can find out how much time does your build took, right? Again, you can capture that information, average it out over a period of time, right, for different microservices, and then create some visualizations around it and share it with your dev teams and engineering managers. Now, this data will help them visualize, or kind of have an insight that there would be certain changes that they have done in the last month, probably it's a time boxed metric, right? So some changes, some new libraries, some new, probably library version upgrades, right, which is causing the builds to take longer time. So they can work on them right away and fix, right? So these metrics would help to find out the problems early, right, in the operations and in the way we are conducting this microservice deployments and testing. There are a few more popular engineering metrics that we'd like to share, right? And right before that, I'd also like to share one more concept which could be used in microservices team, which is this traffic light system, right? You have a red, amber, and a green, signals, right? So why do we capture these metrics, right? That one aspect of it is to know whether we're doing things right or wrong, right? So it's a data point which we can use. But then these data points should be evaluated against some targets, right? For example, my target code coverage should be 90%. So my target is a 90%, and let's say my current value is 80. So which zone I am in? I may be in a red, in a green, or I'm not in green for sure, but am I in green, yellow or red? Which means, do I need to put an immediate effort there, which could be reflected by a red sign, or something which will organically happen over a period of time, and it's just a delay, but we are not completely off track from from our targets. That is where the yellow signal would come. So essentially, you can zone out your metrics, right? Based on these signals, and this will help you again bring more visibility and highlight the risky areas to the engineering heads, up early. Now let's look at some of the other popular engineering metrics, so which the metrics will help your software engineering team as a whole. Okay. PR cycle time, right? That's the time which a PR takes from the point where the first commit was made in this PR to the time it's get merged, right? It essentially is done to evaluate if our PR review process is strong enough. Are we taking more time to do reviews? Are we not putting in the right code standards? Are we not meeting the quality gates and stuff like that? So you can have your PR cycle time, which will help improve dev productivity, right? Because they'll get to know where they are taking more time, because eventually every time taken in the process increases the time to market for the product, right? So PR cycle time, so it's again one of the metric which you can calculate based on the source control management tool which your teams are using, right? The next is lead time. Lead time is a superset of it's a superset metric which will tell you about the speed at which your softwares are delivered as a whole. So it's a time between the point where a change was requested to a change being delivered. So it involves implementation time, testing time, deployment time, making sure that post deployment things are ready for the customers. This entire time for making a change available to the customer is the lead time, right? So this will allow your teams to, and not only your engineering teams, but probably to your business teams as well, that, this is our general velocity of delivering features to the customers. And accordingly, they can, either fix, few roadblocks if the lead time is high, or they could, create their roadmaps, their plans, according to the lead times. Defect leakage. I think we've talked quite a lot about defects today. So the number of defects which are being leaked on staging and production, it's a very important metric to understand, the quality and the standards of code that we are maintaining, particularly when we are investing a lot on white box testing. If we have defects on staging and prod, that means, there's something wrong with our unit or integration test, which is not able to catch these issues early, right? Pipeline health. Now that we are talking about CI/CD pipeline a lot, the health of the pipeline, as in the success rate at which you are able to deploy your builds, is very crucial, right? It basically means that the time, the rate at which your application could be compiled and built successfully versus how many times that pipeline have failed, right? What could be the reasons of failures? One of them could be flaky tests. Another, the other one could be just the capacity of the container where your pipeline is, this job is running. Maybe the build agents have some configuration issue, some authorization issue, which have come up very recently via, some upgrades that have happened. So there could be multiple such reasons which are causing a builds to fail. And for us, for a team to be very, very successful, they should be looking at a very high pipeline success rate, right? I mean, as good as 99%. Why should any of your build fail, right? So that kind of an aggressive target you should have for your pipeline health, and make sure that you're tracking it continuously. Wherever you see that there's a, there are few things which have recently been added and which are causing your pipelines to be unstable, that is the time you go back and, work with the engineering teams to fix it. Next is defect cycle time. So it's the average time your team is taking to fix a defect, right? It's basically an operational metric which suggests the speed and the triaging maturity of your team, right? How quickly your team can grab onto the information on a defect, prioritize it, right, and deliver the fix, right? So faster you're able to fix defects, I mean, it'll your delivery process, your build promotion process would be faster, right? So it's a good metric to figure out whether your teams are paying enough attention to the defects which are being logged, right? And finally, code coverage. We have talked enough about it, but I mean, we'll keep talking about it because this is one of the crucial metric for a, especially for a microservice, because we are spending a lot of time into building unit tests, integration tests, within the microservice itself. So how much of your code, application code, is covered via these unit and integration tests? It's very important to have those code coverage, and not only a number, but code coverage should be a target, right? You will read through a lot of online sources and find that 80 to 85% is a generic code coverage target for microservices teams. But I mean, having it even more aggressive, like 95% or even 100% for certain microservices should be a great goal. So yeah, some of these metrics, I mean, I'll recommend all of you go back and figure out if some of these metrics can directly be consumed in your teams, or if there are more metrics that you can create and identify and capture. The idea or the principle behind it is continuously measuring whether we are in the right direction or not, right? And that is applicable for devs, QAs, and overall engineering. So that was about metrics. Let me move on to the next piece, which is some of the engineering practices that really matters. So now that we have talked a lot about testing activities in detail, right? Defects and all, let's just try to close upon some of the engineering practices, which now that all of us are part of various engineering teams within our projects, it's good to know and advocate certain practices which will help your engineering teams be successful. All right. So let's look some of them which we have carved out based on our experiences. First of them is identifying and following a definition of done. So DOD means definition of done. It's quite a common term. Definition of done essentially is a checklist of items that will that need to be fulfilled to mark something as complete, right? So that means if your user story is picked up, a definition of done should have a checklist where you're talking about making sure that the code is behind your feature flags. If the code is is kind of dependent on some other microservices as well. You have enough tests, or your existing tests are getting updated or not. Are you looking at communicating any contract changes, if at all? Are your logs getting up, if you're adding more logs with your PRs and stuff like that. So your definition of done, and it could be customized to what your microservice objectives are, and what are the modes in which you are deploying, right? But there has to be certain checklist items which you can enforce, either via Jira or any other test, project management tool that you're using, or maybe via some bots that you can attach to your source control management tool. So a bot running on a PR, which will just put a checklist that all right, that PR would be merged only when all the checkboxes are marked. So that the owner of the PR would make sure that okay, logs done, tests in the PR updated, my code coverage under check, right? Communicated to the right teams, done. So things like that. So have a definition of done, right? Otherwise, it's easy to be inconsistent into your delivery. And that is because different microservices would have their different objectives and different pace of deployments. Next is automated pipelines. So whatever we have learned in these past 3 sessions, right? We have been basing all our discussions on the fact that we have a CI/CD pipeline, right? Now, essentially, that means any manual intervention in the build promotion, or which essentially means putting a code from dev's machine to customer's hands. Any manual intervention into this process would only add delays and it's error prone, right? So you have to automate as much as possible, and DevOps or CI/CD is the right answer to this concern. Make sure that your deployments, your test triggers, your artifact publications, all of these are automated via pipelines, right? So that you take least amount of time to make sure that make your code available, for on production, right? So make sure that your CI/CD pipeline, your build promotion strategy is very clear. It has all sorts of validations, as early in the cycle, and then you have your deployments to your test servers, then you have your automated black box regressions, just about enough, and then eventually deployments to prod. Some teams are still doing manual deployments to production, right? But I believe that that is based out of a different strategy altogether. But then we have seen so many teams using a CI/CD pipeline till prod, right? So make sure that you have automated pipelines, and that also means that people who are raising the QA flag, or people who are bearing the QA flags, always advocate about having these pipelines around and making sure that tests are always up and running on the pipelines. Test-driven development, I think Vidhi mentioned it really, really clearly when we're talking about defect retrospections. So test-driven development essentially would help you cover up, all possible edge cases, boundary values upfront, right? So whenever a dev team is reading through the acceptance criteria which have been created by the product, right, starting to implement them should start from identifying the right set of tests for it, right? And then you can start implementation to satisfy those tests. I mean, that is how a usual test-driven development would work, right? For microservices, when there are so many microservices working together to form one feature end to end, right? It's so easy to miss some corner cases, right, for a particular microservice, because that is beyond their control or their scope of development, but their response depends on that, right? So you never know that what particular scenario can fail when things work together, like all the microservices, right? Now, instead, if you start converting your acceptance criteria into tests first, you are non-biased about the implementation style of it, right? You are focusing on the fact that once it is ready, these are the things that I need to make sure are working, right? And then your development starts, right? And it will help you find out what edge cases you would otherwise miss if had you not have tests upfront. So make sure that your teams are doing test-driven development, and it will be one of the great practice which will yield good outputs in quick time. API documentation. So nowadays, when we're talking about a platform built out of multiple microservices which are sharing information between each other, there's an approach which we call as contract first approach, right? Which means that every time you want to create an API and update an API, first make the change in the contract, let your consumers know about the contract changes, and only then start implementations, right? So your API documentation is crucial for not only managing or maintaining the versions of your contracts over a period of time, but also it eases out the integration by your consumers, right? The consumers can look at that documentation and easily integrate with your APIs, right? So they can build their own logics based on responses which are part of your documentation, right? And having a single source of API documentation would keep all inconsistencies away, right? So you can use tools like Swagger, as we have already spoken in the last session, right? Which could allow you to test your APIs and document your APIs on a single instance. So invest enough on API documentation, otherwise it's pretty easy to have integration issues late in the cycle. And one more practice, which is canary testing. So it's a concept which exists now for a few years already, right? But I'll just reintroduce what canary testing is. Essentially, when you are putting your code to customers, but choosing which batch of customers or which cohort of customers would consume this code, is when you're doing a canary test. So you're basically not doing a big bang deployment and making your changes available to everybody at once. You're deciding that you will progressively roll out your changes, right? And you'll select, let's say, 5% of my users will get my new code. Now, what this means that we have 5% of users on the new feature and 95% of the users still using the older feature or the older version of the same feature. Now here is an opportunity that you get feedback, right? So your data analytics tool will show which set of customers, the new ones or the old ones, are using the application more, right? What is the experience? What are the error rates? What is the response? What is the time it is taking for application to behave in a certain way? All this data you can capture and then slowly increase that progressiveness of your rollout from 5% to maybe 20, 50, and so on, right? Unless you get the best of the shape of your code. Again, in a microservices architecture where you have so many multiple services working in isolation, and at the same time they're working together to form a platform, right? However, for the customers, this platform is not directly available. You need to have an experience on top of this customer, right? So you have a UI, right? Like a website or a mobile app or anything like that, right? So for customers to experience the changes which have been made deep down in one of the microservice, right? It is prone to error because, the testing in this conjunction has been done only at the end-to-end layers. right? So there might be some environmental or customer specific issues which you might face, right, with these microservices setup. And hence, rolling out in a canary fashion would help you assess the changes, the feel on the ground, any error rates, any spikes in the usage of the service, right? And accordingly, you can make changes and then roll out again to the limited users. So this way you can do progressive rollout, in a canary manner. So that's one of the great practices that we have seen on ground working really well for the microservices team. So that's how engineering practices would be. And then I think we're now coming down to the conclusion of our webinar series with the takeaways for the day. And I'll emphasize a little on some of these takeaways as well. Keep your black box testing suite as light as possible. So, as Preeti has explained really well, the reasons behind it, right? But this is something which every engineering team needs to understand, that having a bulky end-to-end regression is only adding up to the misery, because it has its own management challenges, maintenance challenges, the cost of making changes in that code, and finding defects at so late in the cycle. So make sure that your black box test suites are lightweight, and more investment, particularly with regards to microservices, is done at the white box test layer. On the right, periodic defect retrospections would result in long-term efficiencies, right? So defect analysis is not a one-time activity. Oh, I got so many bugs, let me analyze, right? With every release or every milestone, which you achieve in your team, then there would be some defects, right? The distribution of defects across priority might change, right? But still, if there's a defect, it was a problem. So treat every single defect equally important, right? From an analysis perspective, because there is some learning out of each defect. A test that you might have missed, a scenario which was, completely forgotten, or maybe a scope change that came very late in the cycle, and so on. So it'll help you fix either things technically or from a process level, right? Capture relevant metrics to measure the ROI. So that is what we were talking about. With so many engineering metrics, QA metrics, you are going to measure the ROI, the effort that you are putting. Is that giving you the right value? Is that giving you the right direction? So start capturing metrics which are relevant to your microservice, your ecosystem. And finally, emphasize on assuring the overall engineering. So this is something that we keep advocating, that for SDETs, the boundaries are not just a story which has come to a QA board, or a QA lane on the Kanban, and you just complete your testing and you're done, right? So we will keep saying that the focus is engineering, right? The focus is improving practices, habits on ground, right? Improvising with the entire dev team. And quality assurance is a byproduct. So if you are making sure that you're doing the things right, you're already assured that you'll build some great quality products, right? So stop taking testing as a phase. Start thinking quality as an engineering responsibility, as a practice which everybody in the team needs to follow. And we be the torchbearers for it. So that is what finally takes us to the end of our webinar series. So I'd like to thank each one of you who joined us over these 3 sessions, right? Thank you for being around, asking your questions, sharing the survey reports, your feedback forms with us. It has really helped us being, passionate about talking on microservices. And we'll make sure that we keep having such sessions down the line as well. Post this session as well, you'll get a feedback form which you can fill and help us improve, right? And we'll soon come back as an organization with another set of events, right? And we'll reach out to all of you through various modes. Now is the time for questions and answers. So I'll take them from the box. Okay, so first question is, do we have any best practice for parallel test execution? So parallel test execution itself is a best practice, right? I mean, but yes, I'd like to pass it on to Preeti. I think this question has been asked to Preeti, so Preeti could answer. What are the best practice around parallel test execution?
Right. Sure. Thanks, Anshul. Thanks, Priya, for asking this. So you So the best practices around your parallel test execution depends on at what layer you're trying to, achieve the parallel test execution. For example, when you're talking about the white box testing, where we do a lot of, we start the dependencies on Docker, we use test containers, or we use local stack, or let's say any emulators for our DBs, right? There's a lot of mocking and stubbing that happens that you means that you're using a lot of resources, right? So in those cases, there are different best practices that needs to be taken up. For example, one is what we see, right? When you run in your local, you might not see this, but when you're running on your CI pipeline, your agents are limited in terms of resources, the memory they have, right? So it's important that you keep your resource utilization optimal while running your test in a CI pipeline. That means you don't start too many servers or Dockers when your tests are running, right? And keep those optimal. So that's going to help you in your text execution, faster. What we have seen is some of the code smells within your test code itself leads to higher text execution, and instead of fixing it, teams go for parallel text execution, which is not a right approach also, right? Also see that you address your test code smells, which leads to higher test execution times. That could be, those smells could be coming from mm, first is using hard weights, not having the right exponential retries within your test code, right? So that could be one. If you're using any let's say retry exponential libraries, right, just like availability for Java, if that is not being used correctly, that can add additional delays to your test. So that needs to be looked upon. Also, what we have seen is as microservices, right, in case there are failures, they do a lot of retry. Sometimes if you are verifying these scenarios and you have not optimized your configurations for your test run, that also results into a higher text execution, right? So you have to look into these configurations also when you test certain scenarios which revolves around retry is working or not. See that minimize your configurations and your test execution becomes faster, right? So that's one area to look into when you're doing your white box testing and parallel test execution, right? The second part is what we usually look at parallel text execution support is either from, let's say, from your testing framework, if you're using TestNG or JUnit, or from Maven, right? So what we have seen is for these white box testing, since they are high in terms of resource utilization, using TestNG or JUnit or Maven for parallel test execution might not be the best way, because running these tests again within the same JVM machine or within the same agent is just going to increase your resource utilization set. And then instead of making your test faster, might become your test flaky. They might just fail because they'll say that there is no memory available tonight, might not be able to start even a Docker, right? So for that, go for your CI. Your CI provides you to start execute your test in multiple agents. You can configure, you can create buckets around your white box test layers, which says that, and run these tests in different agents, and these agents actually runs in parallel as part of your CI pipeline. So it depends on how you configure your CI pipeline and how you run it. So make the most of it from your CI pipeline to run these tests in parallel when it comes to white box testing, right? So when you look into black box text execution, let's say you are talking about end-to-end test or the functional test, right, which are minimal in terms of computation. That means they only pass on a request to your services and then they receive a response. And within the workflow, you might be passing on 2 or 3 requests, and then you receive a response, and then you have assertions to verify if the workflow is working as expected or not. So here, if you see that your JVM computational is not being used fully, and that is where for these tests, you could, you could make use of test framework that you're using to run these tests in parallel. But also see that when you're running these tests in parallel, the number of requests that you're going to pass on to your microservices are also being supported by them, right? And eventually it should be, because you're not going to run a performance test which is going to run in thousands of tests per minute. But you could make use of your test framework to run these tests in parallel. But then they're also an end-to-end test. Keep an eye on that you don't have the hard weights and any exponential, and you make use of exponential retries there.
Awesome. Thank you so much, Preeti. I'll take the next question. So it says, what are the parameters for speeding up the test case suite? I know one parameter is running the test in parallel. Are there any other best practices on CI pipeline? Definitely, yes. Of course, it depends on what kind of tests you have in the CI pipeline, white or black box. But from a pipeline perspective, one thing that comes to my mind is caching of the dependencies, which you can do across multiple jobs, so that the compilation time of your tests is reduced a lot in that. However, it depends on the way you've designed your tests. So for example, UI tests have no hard weights, right? The polling time should be in control, right? For API tests, you have to start measuring the API response times as well, right? So based on those response times, you can validate your tests and have pollings, right? So things like that, and test data. So if your one test is dependent on a test data which is created by some other test, it'll always have dependencies and more time. So to make sure that your tests are running fast and independent, every test needs to should ideally be creating their own test data. All right. So just some of the parameters. The next question is, please reiterate the key differences between canary test and A/B testing. Oh, all right. So A/B testing is essentially dividing your application into multiple parts, as in you want some of your users to use one version of the application, and some of the other customers to use the another version. So this is to measure the effectiveness of whether one version is more useful or more have high usability or customer retention than the other. However, canary is more of a rollout strategy, wherein you are progressively increasing the number of customers which will get the same thing. So you have some changes done and you're just rolling it out to 5% people first. The intent here with canary is that you will eventually make that change available to the 100% customers. With A/B testing, you are finding out which version should be eventually done to the customers. If you have data saying out of the 3 versions available in the A/B test, first of the version got 50% retention and the other 2 got just 25% each. So the first version is what you'll pick and then implement for all 3, for all the customers. So I hope that these, we've answered these questions.
So just to add, right, on the canary testing, one of the intent is to also to contain the customer impact, right? Let's say if you are just rolling out to 5% customers, and if there's any issue reported, so that means your number of customers impacted is still far lesser than if you have really rolled out it to the 100%. So as Anshul have rightly said, the only intent in part of canary testing is to do a progressive rollout where only a small percent, you increase the percentage of the percentage of the users that are going to get the new changes slowly based on the confidence that you get. But the intent is to go to the 100% the end and contain the customer impact if there are any issues observed.
Cool. Thanks, Preet. Okay, we have one more. I think we have 3 minutes, so I'll just quickly read that. On our local framework, we have thread local and factory design patterns, but can it be integrated and applied on Dockerized platform locally and globally? I'm not sure. Preeti, would you like to take this?
It's a little tricky. It depends on what your local framework is. If you have any questions, I would rather say post it on our LinkedIn. Possibly we can discuss more about it and you can in detail look into it. But ideally speaking, to me, it looks like it all depends how you're going to run these test and CI pipelines, right? And your resource utilizations there.
Yeah, and just to add, I think Dockerized platform is more of a it's a container which you can design your way. So whatever image you want to create, right, you can set up a Java based image of of a Docker container, and it will allow you to run the tests in any, if the tests run in any other Java environment, your tests would run in a Dockerized platform as well. So there shouldn't be a problem. But yes, if you want to discuss more, as Preeti said, please reach out to us on LinkedIn and we'll love to help. All right. So I think we are done with the set of questions, and I hope all the questions are answered. If any one of you, wants to connect more or needs any further clarification, do reach out us via the LinkedIn post, or, LinkedIn is the best way to connect with us. And yeah, I think that will mark the end or the conclusion for this series. So, all right. Thank you, everybody. Again, we are on time. Great. Okay. So thank you, and see you all soon in the next set of events that we'll publish the schedule very soon. Thank you, everyone, and good night. Bye-bye.